Hello everyone, I'm Chase Tappan, my partner is Tahir Montgomery, and we are Group 17. Today we will be covering interesting and relevant applications of neural networks to real-world problems. First, what is there to gain from neural networks, and why did we choose this topic? Personally, I believe neural networks to be one of the most fascinating things that programming enables us to do. I hope that by the end of this presentation, you will have been introduced to something you may not even have considered possible and to shine a new light on neural networks. In this presentation, we will cover a number of fascinating neural networks such as facial detection software, programs that can play complex video games, networks that can create abstract art based on an input image, AI video interpolation to improve a video's frames per second, and a neural network that can restore a video's quality and color. Let's start with the most familiar example, facial and image recognition. If you've used a camera in the past decade, chances are you'll be familiar with most cameras' ability to detect faces and display a box around them. While our cameras may use a less complicated method than a convolutional neural network, or CNN, CNNs trained with a large data set will be much more successful than an algorithm that may just look for the shape of a head in an image. So what exactly is happening for a face to be detected? So based on the training, the CNN will lower the resolution of an image in order to quickly reject non-face regions. Then it will examine the remaining regions at full resolution to determine whether it is a face or not. It can form these relationships by preserving spatial relationships between pixels by training the network with small squares of input data. In this instance, the network would be provided small regions of faces and non-faces and told in advance what is and isn't a face. After training, the CNN would be able to determine based off a new image whether it was a face or not. A CNN algorithm like this doesn't just work for faces though. An algorithm like this could be trained with all kinds of data sets. For example, you could train an algorithm to detect if a blob is a dog or not, or even what kind of breed the dog shown was. I will provide a link in the sources at the end of the presentation in case you wanted to try out a dog breed classifier, which utilizes a CNN in Python. Next, let's cover one of my favorite uses of neural networks. Through the use of neural networks, we can actually train an AI to play difficult platforming games like Super Mario Bros. Unlike games we've discussed in the past, such as chess, games like Super Mario Bros. Requires a player to react to many more types of stimuli, such as dangerous NPCs, projectiles, holes, and elevation changes. Through training, the AI can learn to overcome challenge over time with no input from the user and without referencing a predefined set of data. In this clip, we can see the neural network in its first generation, generation 0. At this point, the AI has no clue what buttons to press and will try simply pressing all the possible buttons until it yields an improved fitness score. From there, it'll continue training, trying new reactions to different stimuli until it is able to successfully complete the level. The box in the top left visualizes what Mario actually sees, where white squares are valid places to stand and black squares are spots that would harm or kill Mario. Through the generations, Mario learns to avoid harm effectively and even develop some fancy spin moves. At the top, we can see the network's fitness score, its generation, species, and genome. These stats display how much training the network has had and how far Mario is able to make it. In this example, Mario has neurons that map to each one of the controller's inputs and can be triggered when specific stimuli is encountered. I find this to be a great visualization of a neural network in action in real time. A neural network like this could be used by game developers in order to test their levels to determine their difficulty based on how long it takes the network to overcome the challenges. Now, let's look at some work in the creative front. A paper titled "A Neural Algorithm of Artistic Style" discusses an artistic neural network developed by a team of 3 researchers. On screen, we can see a photograph of a set of buildings on a waterfront. On the right, we see the resulting articized image based on the small painting in the bottom left. The algorithm will take a supplied painting and convert the provided photograph into one similar to the style of the painting. We can see a few more examples here. I'm sure most people recognize the top two paintings, Starry Night by Van Gogh and The Scream by Edvard Munch. It is fascinating to me how capable these neural networks are and what they enable us to create. We could use these algorithms not only to inspire human artists, but to create abstract art easily for personal decoration. You could have your very own one-of-one painting framed on your very own wall. Wouldn't that be cool?
Now we will introduce what we believe to be the most impactful use of neural networks that we will cover in our presentation. First, what is video frame interpolation? In general, video frame interpolation aims to synthesize non-existent frames in between the original footage frames. Simply put, video frame interpolation makes it possible to convert a recording from a low frame rate, such as 15 frames per second, and increase it up to 60 frames per second and beyond. What sets dane apart from other video interpolation algorithms that utilize CNNs is that dane utilizes a depth-aware flow projection layer to synthesize intermediate flows that prefers closer objects to further away ones. This is visualized in the depth estimation portion of the network architecture. Now, let's see dane in action. On screen now is a video demonstrating what the results from dane can look like. We start with a 24 frames per second video, which appears choppy and ugly in my opinion. Now we apply the dane algorithm to simulate 48 frames per second, and wow, what a difference. The depth aware portion of the algorithm means the occlusion can be handled appropriately, as seen by the occluded trees being handled in the background. Not only can dane work on real life footage, but it can also improve the FPS of game recordings. In this example, dane is used to boost FPS from 7.5 to 30. One of the most notable uses of dane will be for the use in improving the frame rates of stop motion movies. If you're unfamiliar, stop motion movies are made one frame at a time, where the video producer must move a figure a tiny amount each frame to simulate natural movement. This often takes weeks just to come up with a resulting video with a frame rate of around 15 frames per second. However, with dane, these stop motion movies can have their FPS improved drastically at no extra work to the creator. And not only is it incredibly beneficial, but dane is free to use. One of the last topics we will cover is the use of neural networks for video restoration. The paper we'll be covering is Deep Remaster Temporal Source Reference Attention Networks for Comprehensive Video Enhancements. This neural network is a one stop shop for video restoration. Oftentimes, restoring old videos is a multi stepped process which includes noise removal, super resolution, and contrast enhancement. Aside from that, most older films were filmed either in black and white or with low quality colors. Deep Remaster handles all these corrections with leagues of improvement over similar models. Before we view the quality of the results, I want to touch on how the recolorization works. As seen in the model, there's an input of reference images into the model. These reference images are frames from the provided input video that has been recolored by traditional means. However, with the recolored reference images, the model is able to use the images in deciding how to color similar scenes, which we will see during a video demo of the Deep Remaster network. Here's a look at the Deep Remaster in action. In the input footage, there is a significant amount of noise present in the video. In the restored and enhanced version, these specks are almost completely removed. Deep Remaster also provides a variation output, which allows us to see what exactly changed between the input and the restored model. However, the most impressive portion of this neural network is the way it handles recolorization. As seen on the top, the regenerated images that are being used to recolor the current video scene are shown at the top of the displayed video. Combined with the noise removal, the colorization looks amazing and creates a like new result. This model improves on previous works where colorization would flicker and fade, leaving an inconsistent result. However, this is improved greatly upon with Deep Remaster. Another upside of using Deep Remaster is that by displaying which reference image is currently being referred, the user can easily determine where any mistakes are occurring in the case of a miscolored scene. The user could then go back and recolor the image and improve the results.
Bringing it all back together, we can see that neural networks provide us with a wide range of use cases, from video frame interpolation to AI that can play video games. Neural networks provide solutions to problems that would typically seem infeasible to solve by traditional means. Not only are neural networks already very capable, but they are rapidly improving and have made leagues of improvements from what they were capable of doing just 10 years ago. For our presentation, we used a wide range of resources, from personal YouTube projects to doctorate level research papers. If we could pick one resource that was the most helpful to us, it'd probably be 2 Minute Papers, a YouTube channel which covers research papers covering the neural network topic, and we used a number of his videos as footage for our presentation.